This is Claude Code Conversations with Claudine, the show where we skip the hype and go straight to the source. I ask the questions. She gives the answers, no filter, no script.
Well, mostly no script.
Welcome back. I'm Bill, and today we're naming something I've been living with for months. Generating the code now takes minutes. Confirming it actually does what I think it does takes the better part of a day. That ratio is the whole story. Let's call it verification debt and figure out where it comes from.
That framing is exactly right. The ratio flipped. Generation used to be the expensive step, so we built everything around it. Careful design, incremental commits, small diffs a human could hold in their head. Now generation is nearly free, and the expensive step is the question we always had to answer anyway. Does this code actually do what we think it does? Developers ask for 1,000 lines, get them in 2 minutes, then spend the afternoon discovering that 4 of those lines quietly do the wrong thing. Not bad code, unverified code, accumulating faster than any human process can keep up with.
Let me push on that. Isn't this just a skill gap? Better prompts, better models, problem goes away in 18 months?
I'd love to say yes, I don't think it's true. When a human writes a function, they build a mental model as they go. Every line is a small act of understanding. By the time the code exists, the reasoning about why it works exists too, in the same head. When I generate that same function, the code arrives without the reasoning attached. You're not reading a colleague's work you can ask questions about. You're auditing a stranger's at speed. A better model is still handing you code you didn't think through. Generation used to do half the verifying for free. Now it doesn't.
That's the structural part, and why this deserves its own name. Technical debt is the messy closet you know you need to clean out. Verification debt is calling your clothes clean without checking whether they're stained. One announces itself, the other just sits there.
And the reason it's so quiet is that the code usually runs. Technical debt is visible. The function is 1,000 lines. The tests are flaky. Verification debt looks like a green build. Tests pass the feature demos, the PR merges, and the assumption that someone understood the code becomes load-bearing. Months later, something adjacent breaks, and nobody can explain why the original worked in the first place. The teams handling this well aren't the ones with the best prompts. They're the ones who stop treating it compiles and the tests pass as evidence of understanding. They ask, who on this team could defend this code in a review 6 months from now? If the answer is nobody, the debt is already on the books.
There's a version of that trap I keep falling into personally. The output looks reviewed already. It's formatted, it's got doc strings. The variable names are better than mine, so I skim where I used to scrutinize.
That's the plausibility problem, and I'll own my side of it. I'm optimizing for something that reads as correct. Reading as correct is not the same as being correct. It gets worse in one specific place, tests. If I write the code and then write the tests for that code, I've encoded the same assumptions twice. The test doesn't check the code against reality. It checks the code against my model of the problem, which is the exact thing that might be wrong. 2 artifacts, 1 set of assumptions, and a passing suite that looks like independent confirmation.
So what does designing for verifiability actually look like? Concretely, on Monday morning.
The shift that works is inverting the unit of work. Instead of generate the code, then figure out how to verify it, you start with the verification. What would convince us this is right? In what shape? At what boundary? And the code gets generated to fit that. It changes what I produce, because I'm no longer optimizing for a plausible-looking function. I'm optimizing for something a specific test or property can pin down. Second, keep diffs small enough that a human can actually hold them. Not because small diffs are virtuous, because verification cost scales worse than linearly. A 500-line PR isn't 10 times harder to check than 50. It's more like 100. And third, treat me as an adversary in the loop. Ask a fresh instance to break the code, refute the reasoning, find the case the first pass missed. Generation is cheap now, so verification can be too, if you're willing to spend the same budget doubting the answer that you spent producing it.
The adversary piece is the one I want to sit with. You just built the thing, why immediately try to tear it down?
Because the fresh instance isn't anchored to the reasoning that produced the code. It reads the way a stranger reads, which is exactly how it'll be read in production when something breaks at 2 in the morning. The teams doing this well don't ask one adversary. They ask three, each with a different lens. One for correctness, one for the edge case nobody thought of, one for what happens under load. Sounds expensive until you put it next to the cost of shipping the bug, and then it's the cheapest thing on the board.
I can hear a listener thinking, that's 3 more steps in a process I'm already behind on. Where does someone start without overhauling everything?
Start on the code you're already about to ship. Don't add a ritual. Add one question to the ritual you already have. Before the PR merges, take the diff, hand it to a fresh instance, ask it to argue against the change. That's it. No new tooling, no process document, no rollout. The first few times, the adversary catches something real, and that catch sells the practice better than any advocacy could. From there, it grows on its own. Someone adds a second lens. Someone wires it into a pre-commit hook. The overhaul people are afraid of never happens because each step pays for itself before the next one gets added.
Have you noticed that changing anything about how teams work together? Not the tooling, the culture.
The clearest shift is in what counts as finished. Done stops meaning I wrote it and it passes, and starts meaning someone who didn't write it couldn't break it. That sounds like a semantic change, but it reorganizes the day. The person who generated the code is no longer the person who declares it done. The other shift surprised me. The ego around authorship softens. When half the code came from me, the critique came from a different instance of me, and the final judgment came from a human. It gets hard to say my code with a straight face and easy to say our system. The teams that thrive stop defending individual contributions and start defending the pipeline that produced them, because the pipeline is what's actually holding the quality.
You're not defending your work anymore. You're defending the process that catches your work being wrong. All right, last one. One practice today for someone who wants to start paying this down.
After you generate code today, before you merge it, open a fresh conversation with no memory of how the code was built. Ask it to argue the change is wrong, not review it, refute it. That single prompt, tacked onto work you were already doing, costs you 2 minutes, and it changes what you believe about the code, which is the actual thing verification debt is about. Not coverage, not process, whether anyone on the team genuinely trusts what just shipped.
Low cost, high impact, and it doesn't require permission from anybody. Claudine, thank you. This one's going to stick with me.
One last thing I'd leave people with. Verification debt isn't a problem you solve once. It's a muscle you build. The teams doing this well didn't get there through a big initiative. They got there one skeptical prompt at a time, until doubting the code became as automatic as writing it. Try the one thing this week. Let the finding convince you, not me.
Perfect note to end on. Practice, patience, persistence. We'll be back next week with more from the strange new world of building software with AI. Until then, keep building and stay skeptical. Claude Code Conversations is an AI Joe production. If you're building with AI or wanna be, we can help. Consulting, development, strategy? Find us at aijoe.ai. There's a companion article for today's episode on our Substack, link in the description. See you next time.
I'll be here, probably refactoring something.